Alright, now we've got Algebra, Chapter 2, Section 6, Monitoring Progress, numbers 1 through 6. More solving inequalities, this time absolute value inequalities. So let's take a look. Now here, notice that we've got the absolute value of x is less than or equal to 3.5. Remember, absolute value means the distance from 0 on the number line. So we're asking ourselves what numbers have an absolute value, a distance from 0 on the number line that's less than 3.5. Well, we're going to split this into two separate inequalities, just like we do with equations. So either x is got to be greater than or equal to negative 3.5, right? And what, actually, I'm sorry, I shouldn't say either, it's and x has to be less than or equal to positive 3.5. All right, so x has got to be someplace between negative 3.5 and positive 3.5. Any number that's in between those two will have a distance from 0 on the number line that is less than or equal to 3.5. So when we go to graph that, all right, we've got 3.5 right here, and negative 3.5, 3.5 right here. So it's going to be any number that's in between negative 3.5 and positive 3.5. Any number in here is going to have an absolute value, a distance from 0 on the number line that's less than 3.5. So this is a lot like solving absolute value equations. We're still going to split it into two separate inequalities, just like we did before, except instead of having just two answers, like two separate solutions, we're going to have a range of solutions that falls in between two numbers. Let's take a look at another one. All right, here, absolute value of k minus 3 is less than negative 1. Now, think about this. Absolute value could never be less than negative 1. So no matter what I put in for k, doesn't matter what this turns out to be, its distance will never be less than a negative number because distances are always positive. So this one has no solutions. All right, absolute value can never be negative. All right, now here, absolute value of 2w minus 1 less than 11. Now the key here is anytime you're dealing with absolute value being less than a number, you're saying its distance from 0 on the number line. So here's my number line, there's 0. Its distance is somewhere in between negative 11 and positive 11. So it's bigger than negative 11, but also less than positive 11. So this is going to be an and, a compound inequality that involves an and. So that means that negative 11 and positive 11, somewhere between these two, is going to be the 2w minus 1. And notice that since we've got a less than and it's not less than or equal to, these both turn into less thans and not equal to. So again, anytime that your inequality in the absolute value inequality is less than some number, right, it's always going to turn out to be an and inequality. So let's take a look here. Well, we're going to add 1 to both sides, and that's going to leave us with let's see, negative 10 less than 2w less than 12. We're going to divide by 2 on both sides, of course, for both equations. We get negative 5 less than w less than 6. So w is in between negative 5 and positive 6. So if w itself is between negative 5 and positive 6, then the absolute value of 2w minus 1 will be less than 11. That expression will fall in this range somewhere. Okay. Let's go ahead and graph that. And all right, so we're just going to go ahead and mark -5 and +6. And since this is an AND inequality, then we just put a line between them. Since these are both, they're not and equal to or equal to inequalities, so we don't fill in the circles. Next. Okay, we've got, in this case, this is a greater than inequality. So here they're saying that this expression x plus 3, its distance from 0 is greater than 8, which means that the whole expression is someplace outside that range. So it's either going to be, someplace out here, right, greater than 8, or it's going to be someplace down here less than -8. The only place it can't be is in between. So this is going to turn out to be an OR inequality. It's going to be either up here or down here. So anytime you see greater than, right, like this, that translates into an OR compound inequality. So we've got that x plus 3, whatever's in there, that expression, is either going to turn out to be less than -8, or x plus 3 is going to turn out to be greater than +8. And we'll have to solve them separately. So let's see, subtract 3, x is less than -11, or subtract 3, x is greater than 5. So let's go ahead and graph that. So let's see, here is -11, here is 5, and so either x is someplace out here or it's someplace down here. So remember, if x itself is less than -11 or greater than 5, then that expression, the x plus 3, is going to be someplace outside that -8 to +8 interval. All right, next. Again, we're dealing with a greater than inequality. So this is going to be another OR compound inequality. But before we can even split it, we're going to have to get the absolute value by itself by getting rid of that -3 there. So let's take a look. We've got absolute value of n plus 2 is greater than or equal to -6 plus 3 is -3. Now at this point we can stop, and here's why. Whatever's in here, right, if we're dealing with absolute value is always positive. And no matter what I put in here, it's going to have a positive distance from 0 on the number line, which means it's always going to be bigger than -3. So I can put any number in for n, and the distance, and I add 2 to it, and its distance from 0 will always be bigger than -3. So all real numbers are the solution, meaning I could put any number, substitute it for n, add 2 to it, and its distance from 0, its absolute value, its distance from 0 on the number line is going to be bigger, greater than -3. Next. All right, so last one here. Again, we're dealing with a greater than, which means this is going to turn out to be an OR inequality. But before we can even get to that, we're going to have to get rid of some stuff here. Let's see, first we want the term. We're going to treat this d plus 1 almost like it's its whole variable itself. And we want to get rid of all the other terms, right? So we're going to get rid of this -7 by adding 7 to both sides. And that leaves us with 3 times the absolute value of d plus 1 is greater than or equal to -1 plus 7, which is 6. Then we're going to divide by 3 on both sides, and that gives us absolute value of d plus 1 is greater than or equal to 2. Alright, so we're going to go ahead and split this inequality. Just remember, whatever d plus 1 is, there's 0, there's 2, there's negative 2. Whatever d plus 1 is, it's going to be either out here somewhere or it's going to be down here somewhere. So whatever d plus 1 is, its distance from 0, its absolute value, has to be bigger than 2, meaning that it's out here above 2 or it's down here below negative 2. And to go and write that out, we got d plus 1 either is less than or equal to negative 2, or d plus 1 is greater than or equal to positive 2. So then to solve, we'll subtract 1 from both sides, and we end up with d is less than or equal to negative 3, or on the other side, subtract 1, and we've got d is greater than or equal to 1. So let's go take a look at what that looks like on the graph. So let's see, negative 3, 1, 2, 3 in the negative, or 1. So d is either less than negative 3 or greater than positive 1. Awesome, and we're done.